In March 2025, the ground beneath southern Italy began exhibiting signs of unusual and potentially alarming activity. At exactly 3:42 in the morning, on March 13th, a magnitude 4.4 earthquake shook the Campi Flegrei caldera near Naples. Residents in Pozzuoli awoke to violent shaking that toppled furniture, cracked windows, and sparked widespread panic. Within minutes, emergency lines were flooded with calls reporting an even more unsettling phenomenon: steam rising from newly formed fractures in streets, parking lots, and the basements of buildings. The sight of steam hissing from asphalt in the dead of night was surreal and terrifying, a vivid reminder that the ground beneath the city was alive and shifting. Though the earthquake itself was notable, it was only the beginning of a much larger and more complex geological sequence. When seismologists analyzed the tremor in detail, they discovered something unusual. Embedded within the main quake were tens of thousands of microtremors, subtle vibrations suggesting small-scale fractures propagating through the caldera's crust. This indicated that the caldera was not merely experiencing a single isolated event, but was undergoing internal structural changes at depth, potentially altering the dynamics of the system. These internal stress changes can sometimes precede larger eruptions, but the precise triggers and outcomes are inherently uncertain, making continuous observation essential. Even more concerning was the direction of this stress. Seismic imaging revealed that the rupture had opened, or possibly reactivated, a deep conduit extending nearly 8 kilometers underground. This newly active pathway appeared to trend toward Mount Vesuvius, the infamous volcano that destroyed Pompeii in AD 79. For decades, Campi Flegrei and Vesuvius were monitored separately, treated as distinct systems. The new data suggested that pressure changes in one system might influence the other, challenging long-standing assumptions and raising questions about the potential for simultaneous unrest. Campi Flegrei is not a conventional cone-shaped volcano. It is an enormous caldera, roughly 8 miles wide, formed by massive eruptions tens of thousands of years ago. Beneath its surface lies a complex network of interconnected magma chambers and hydrothermal reservoirs. Since the 1950s, regions of the caldera have undergone bradyseism, a gradual uplift caused by magma and underground fluids accumulating beneath the surface. In some areas, the ground has risen more than 4 meters over decades. In recent years, the uplift has accelerated, reaching rates of approximately 2 centimeters per month. Alongside this uplift, steam vent activity has intensified. Gas emissions, particularly carbon dioxide and sulfur compounds, have increased, and thermal monitoring has detected localized temperature spikes along newly fractured zones. These changes prompted scientists to install additional instruments to measure ground deformation, gas composition, and subsurface temperature in real time, allowing them to detect even the most subtle shifts. Within 48 hours of the March 13th earthquake, instruments at Mount Vesuvius began recording deeper than usual seismic signals, originating from the depths of its magmatic system rather than the surface. Unlike surface tremors, these deep signals reflect movements within magma chambers, suggesting that underground pressure conditions are evolving. While these signals do not guarantee an eruption, they point to a possible dynamic connection between Campi Flegrei and Vesuvius. This challenges traditional notions of volcanoes as isolated systems, highlighting the complexity of subterranean magmatic networks and forcing scientists to rethink assumptions about how these volcanoes interact. Southern Italy sits at the boundary of the African and Eurasian tectonic plates, a region shaped by millions of years of geological activity. The Campanian volcanic arc, including Campi Flegrei, Vesuvius, and nearby Ischia, has been molded by both tectonic movement and magmatic activity over hundreds of thousands of years. Seismic tomography has long suggested that deep magma reservoirs extend across the region, connecting these volcanoes through shared structural roots. The March rupture has reignited discussion about whether pressure changes in one volcano could propagate to another, adding urgency to monitoring and risk analysis. Historically, Campi Flegrei has experienced repeated cycles of unrest. Between 1982 and 1984, more than 16,000 earthquakes were recorded during a major uplift event, prompting temporary evacuations of thousands of residents in Pozzuoli. While that crisis subsided without eruption, it demonstrated the potential for rapid ground movement and the societal challenges of responding to volcanic unrest. The current situation is distinct because seismic activity appears aligned along a fault corridor trending toward Vesuvius. Thermal imaging has revealed warming along parts of this corridor, and shifts in gas chemistry suggest deeper magmatic contributions rather than purely hydrothermal emissions. Italian authorities have responded by raising monitoring levels and updating emergency protocols. Italy's Civil Protection Department now evaluates Campi Flegrei and Vesuvius under a coordinated risk framework, recognizing that simultaneous unrest could create unprecedented logistical challenges. The greater Naples metropolitan area, home to more than 3 million residents, requires detailed evacuation planning, including transportation, shelter, and communication strategies. Historically, contingency plans assumed activity at a single volcano at a time. Today, emergency planners are preparing for scenarios involving simultaneous unrest at both systems, a task demanding extensive coordination and infrastructure investment. Beyond Italy, scientists are closely observing these developments. Researchers are studying whether pressure redistribution within one section of the magmatic system could influence other Mediterranean volcanoes, such as Mount Etna or Stromboli. While no coordinated activation has been observed, volcanic arcs often share deep structural roots, making continued monitoring essential. International teams now work alongside Italian observatories, deploying instruments to track ground deformation, gas emissions, and thermal anomalies. This collaboration improves forecasting accuracy and ensures that unexpected changes are detected quickly. Separating confirmed data from speculation is essential. Models suggest that the March rupture created a potential stress transfer pathway between Campi Flegrei and Vesuvius, but this does not guarantee a joint eruption. Volcanic conduits can open and seal repeatedly without surface activity. Magma movement is governed by multiple factors: pressure, composition, rock strength, and dynamic interactions in the crust, making precise predictions inherently difficult. Campi Flegrei's history highlights its potential. Around 39,000 years ago, the Campanian ignimbrite eruption dispersed ash across Europe and influenced global climate patterns. A later eruption 15,000 years ago reshaped the caldera's landscape. These events demonstrate the caldera's capacity for explosive activity, even under conditions different from today. Modern monitoring tools, satellite radar with millimeter precision, AI-assisted seismic data analysis, gas sensors tracking chemical changes, and thermal imaging allow scientists to detect early warning signs that would have been impossible decades ago. Despite technological advances, forecasting eruptions remains uncertain. Subsurface processes occur kilometers below the surface and are influenced by dynamic variables beyond observation. Residents of Naples and surrounding communities continue daily routines. Cafes open, children attend school, ferries cross the bay, and streets bustle with life. Yet the visible steam vents, pavement cracks, and tremors serve as constant reminders of the latent power beneath. Emergency drills are being updated, hospitals are reviewing surge capacity plans, airlines refine ash cloud response procedures. Agricultural agencies assess potential impacts on crops and livestock. International researchers collaborate with Italian observatories to share expertise and refine models. Each data set, seismic, thermal, or chemical, adds another piece to the complex geological puzzle, helping scientists understand the evolving relationship between Campi Flegrei and Vesuvius. The central question is no longer whether unrest is occurring, it clearly is, but how these systems will interact over time. Will pressures stabilize as in previous crises or continue to accumulate, raising the risk of a larger, potentially catastrophic event? Most periods of volcanic unrest worldwide do not result in eruptions. Yet the dense population in Naples means that even moderate activity could have significant consequences. Ongoing monitoring of ground deformation, fluctuating gas emissions, and persistent microseismicity feeds increasingly sophisticated predictive models. Scientists explore a range of scenarios from stabilization to eruption, fully aware of the stakes. The ground beneath southern Italy is now in a phase of heightened activity, whose outcome remains uncertain. What is certain is that this region represents one of the most closely watched volcanic landscapes on Earth, with millions relying on vigilance, preparedness, and clear communication. The forces shaping this landscape have operated for hundreds of thousands of years. Understanding their behavior today, particularly how multiple volcanic systems interact, may determine how safely southern Italy navigates future events. Scientific observation, advanced technology, and community preparedness converge here, in a region where history, geology, and society intersect in a delicate balance. The events of March 2025 underscore that volcanic systems are living, dynamic, and capable of surprising even experienced scientists. They highlight the importance of advanced monitoring networks, emergency infrastructure, and public awareness. For millions living in the shadow of Campi Flegrei and Vesuvius, vigilance is essential. Every crack, plume of steam, and tremor provides data and warnings, guiding scientists and authorities in their mission to protect lives and property. Researchers continue to refine models, study deep magmatic connections, and share expertise internationally. Lessons learned in southern Italy could influence volcanic monitoring strategies worldwide, improving risk assessment, emergency planning, and global preparedness for volcanic events in densely populated regions. The ground beneath southern Italy is changing, and with it, the future of volcanic science, public safety, and community resilience is entering a critical and unprecedented phase. The human element cannot be overlooked. Families in Pozzuoli and Naples live under the constant awareness of what lies beneath, adjusting daily life to accommodate potential risks. Schools conduct regular drills. Local governments disseminate information about evacuation routes and emergency supplies. Businesses assess continuity plans, and tourism operators prepare for contingencies. This collective vigilance is as much a part of the region's survival strategy as scientific monitoring. Geologically, the interaction between magma, hydrothermal fluids, and tectonic stress creates a delicate, dynamic system. Hydrothermal reservoirs can amplify pressure changes, while faults act as both conduits and barriers. The March 2025 rupture demonstrates how interconnected these processes can be, highlighting the need for multidisciplinary study from geochemistry to geophysics.